Chapter 8, Lesson 1, Applying Exponent Properties Involving Products. So what we're going to be dealing with now is we're going to be moving on to talking about exponents and powers. And this is a lot about adding. And so just pay attention, and there's some rules that you need to know. So one thing to understand is this, that an exponent is a part of what is called a power. This is a power. It's 2, and then the exponent to the third power, this is 2 cubed. And the 2 part is the base, and the 3 part is the exponent. So if we were to write this out, it would be 2 times 2 times 2 if we were to write out in factors. So that's just a reminder of what that means. And so for this one here, it says here, identify the exponent and the base in the expression 13 to the little tiny 8. That means the exponent is 8, the base is 13, and it would be 13 times 13 times 13, 8 times. So let's look at this now. There's the power of products property, which means that if you, it says here, it tells us that when we multiply the same base number with exponents, we can add exponents. So it says here x to the third power times x to the fifth power is equal to x to the third plus 3 plus fifth power, so that's x to the 8th power. Let's look at a couple of examples here in a second here, but so this just x to the m times x to the n is equal to x to the m plus n. So for example, for this one right here, this is 8 to the third power times 8 to the 11th power, so you just add 3 and 11, you get 8 to the 14th power. This one here, a lot of students have difficulty with this because there's not a power in front of that first 6, or there's not an exponent for that first 6. So if ever that's the case, then it's just 6 to the first power. If it helps you to do that instead, to rewrite it, that's fine. So this is going to be 6 to the 4th power. For this one here, it's going to be, well, we got the bases are all the same, so we can just add the exponents. So it's going to be adding 3, 6, and then 2, so that's going to be y to the 11th power. And down here, this one here, remember, this one here is to the first power, so it's just going to be negative 10 because the base is the same, to the 2 plus 1 plus 5. 2 plus 1 is 3 plus 5 is going to be to the 8th power. So that's what happens. It's just adding. Now the power of products, power property states that to find the power of a power, you multiply the exponents. Now this is very different. What it means is, and I'll write this out again as an example here. This is as x to the second power, but then that whole thing is to the 5th power. In that case there, you've got to multiply the 2 times the 5 to get the right power, so it's going to be x to the 10th power. So that's just an example, and here the rule is listed there. So for this one right here, where we have 3 to the 3rd power and the whole thing to the 6th power, it's going to end up being 3 to the 18th power because it's going to be 3 times 6. For this one right here, that's going to be 13 to the 30th power because it's 3 and 13 to the 3rd power to the 10th power. For this one here, it's going to be d to the 12th power because it's going to be 4 times 3. Now you notice the important difference here is that there's not another power, or there's not another base there that you're multiplying that has the same base, so you can't just add the exponents. For this one here, it's going to be f to the 10th power. And for this one here, it's going to be negative 12 to the, let's see here, it's going to be negative 12 to the 13th power. And this is pretty straightforward, I think, but I'm just going to do these two as well. I'm going to clear that out for a second just to make sure it's clear. For these two, they're a little bit more specific, but this is w plus 8, still at that. And then it's 9 to the 9th power, and then that whole thing to the second power, so that's going to be to the 18th power for there. Don't worry that it still is that it is a larger expression, it still is the same rule because you've still have those parentheses around it. So this is going to be to the 12th power for that one. So the power of product property states that to find a power of a product, find the power of each factor and multiply. So what you can do is, in this case here, when you have 3 times 4, and that whole thing is to the 3rd power, you can kind of transfer that power, or that exponent, to both of them. So it's going to be 3 to the 3rd times 4 to the 3rd. That's the same thing. So you can sort of this is sort of like the distributive property. You can distribute that exponent to both separately. So for here, it's just going to be 16 to the 4th times 21 to the 4th. For here, it's going to be 6 to the 3rd times m to the 3rd times n to the 3rd. And then you multiply these out. For here, it's going to be -5. And for this one here, I'm going to go ahead and separate a little bit because there's that negative sign, to the 3rd power times p to the 3rd power. The reason why I did this one specifically like that is because that -3 or -5 is going to be -5 times -5 times -5. So that's going to be -125, and that's going to be p to the 3rd power. Remember, negative times negative times negative is going to be a negative, not a positive. So very important thing that a lot of students have difficulty with between these two. In this case here, this is going to be 2 to the 4th power. We're going to take the negative of it in the end, and q to the 4th power. So this is going to be 2 times 2 times 2 times 2. So it's going to be 16 q to the 4th. But we're taking the negative of it. That's why that negative sign is on the outside. For here, it's going to be -2 to the 4th power and q to the 4th power. So -2 to the 4th power is going to be 16 because -2 times -2 is 4, times -2 is -8, times -2 is going to be 16. So that's an important difference. So obviously negative versus positive there. So again, in terms of simplifying all these ones, it's the same pattern here. I'm going to do a couple of the tougher ones here. Well, I already did one like that, but I'll do this again. This is going to be -3 2nd power, and then n to the 2nd power. So this is going to be 9 n to the 2nd power. For this one here, that's a little bit more complex. So let's do this. This is going to be 2 to the 3rd power, m to the 3rd power, times, then we got m, and then we got that 4m to the 4th power, and then that whole thing to the 3rd power. So that's going to be m to the 12th power. So we can then combine these. This is going to be 8m cubed m to the 12th. And then it's going to combine to m to the 15th power. Same sort of thing here. You're going to go ahead and this to the 3rd power here, so it's going to be -3 to the 3rd power. Then, but here you've got a power to a power, so it's going to be a multiplication there, so it's going to be y to the 15th power times 2. So that's sort of like the other problem, it's just reversed. So -3 times -3 times -3 is going to be -27. Remember, the negative sign is included in there, so you've got to multiply the negative by the negative by the negative, not like the other one where you have the negative on the outside. Times 2 y to the 2nd power. And then we can multiply this out, number to number. That's going to be -54. And then power to power, it's going to be y to the 17th. And that's how it works.